right. Hi, everyone. It's nice to see all these folks join us and excited to have this presentation today. Very excited to have Professor Tyron Shu here. We had some challenges last time, so it was great to be able to get this in. We're very excited to have him here today. And thank you, everybody, for joining us. I think we're going to begin with the land acknowledgement, if I'm correct. Oh, I do the thank yous first. Okay. Vin needs to remember the order of the slides. Well, there's a number of people to thank who bring this together. This is a partnership of the library and the Office of the Provost, along with the College of Engineering, the Spartan Bookstore, and the Division of Research and Innovation. And today we're having, very excitingly, a live presentation from the library itself. For those who want, there's live captioning available, and just as recognition that the webinar is being recorded. If you have questions, I'll be moderating those at the end of the talk. Please use the Q&A function in the bottom bar of the window for the webinar to place your questions. We'll be able to answer those as best we can given the time we have. I would like to, before we formally begin the program then, read out our land acknowledgement. The San Jose State University community recognizes that the present-day Muwekma Ohlone tribe, with an enrolled Bureau of Indian Affairs documented membership of over 550, is comprised of all the known surviving American Indian lineages aboriginal to the San Francisco Bay region, who trace their ancestry through the missions Santa Clara, San Jose, and Dolores during the advent of the Hispano-European Empire into Alta California, and who are the successors and living members of the sovereign, historic, previously federally recognized Verona Band of Alameda County. Furthermore, the San Jose State University community recognizes that the university is established within the Tamiyan Ohlone-speaking tribal ethno-historic territory, which, based upon the unratified federal treaties of 1851-1852, includes the unceded ancestral lands of the Muwekma Ohlone tribe of the San Francisco Bay Area. Some of the enrolled Muwekma lineages are descended from the direct ancestors from the Tamiyan Ohlone tribal territory, whose ancestors had affiliation with the Mission Santa Clara. The San Jose State University community also recognized the importance of this land to the indigenous Muwekma Ohlone people of this region.
Can you hear?
And consistent with our principles of community and diversity, strive to be good stewards on behalf of the Muwekma Ohlone tribe whose land we occupy. With that acknowledgement then, I would like to introduce today's speaker, Professor Tyron Shu from Mechanical Engineering. Dr. Shu joined in 1990 as professor and chair of mechanical engineering. He had a productive career at the University of Manitoba before he arrived here, establishing several really exciting Natural Science and Engineering Research Council professorships. His work has been multifaceted and ongoing as someone who focuses on design engineering and heat exchange, steam power plant equipment, and advanced structural design of large steam turbines, as well as nuclear reactor fuel systems for major industries in both the US and Canada. He's authored a multitude of textbooks and edited volumes and so forth on finite element methods and thermomechanics and microelectrical packaging. It is my pleasure to introduce him today, where he'll be talking about his current research and some of his interests in STEM education. Dr. Shu, please, the stage is yours.
Well, thank you very much, Pavel Del Casino. I'm glad that I'm here. Well, to the audience, welcome to attend my presentation. Please first accept my sincere apology for having to reschedule this presentation from the month of March to today. I hope that this rescheduling had not caused too much inconvenience to you, I, of course, would also like to thank RESCA Council and the Provo Del Casino for having selected me to be the university scholar this year and to share my experience in establishing a mechatronic education program at our university. And I think this program that I selected and I pioneered would serve a very good educational opportunities for our students and also to our community as well. Well, today I'm going to share my experience with you on how we establish this program with a very generous support by National Science Foundation and also the local Silicon Valley high-tech industry and business. And also I'd like to express my sincere appreciation for the library staff, in particular like Leslie and Maria, and also for Melanie from Provost office for making the arrangement. And without them, I won't be able to make my presentation today. And also I'd like to express my sincere appreciation for the bookstore and also the library for their help, their sponsorship of this presentation. So without further ado, I'd like to start my presentation. And first, I'd like to briefly introduce to you what is mechatronics and the STEM education. I'm sure these two terms would be familiar to you all, but how am I going to relate mechatronic education and human resource development and STEM education, as I would do in my later part of my presentation. And also, I'd like to share with you how I believe we can use these two technology and forms of technologies to solve two of today's very pressing problems in humanity. First of all, what is the mechatronics? Well, simply put it, mechatronics is a blend of two English words that is the first part of the mechanics and mechanical blended together with second part of the word electronics. So put these two parts together, you will see, as I have shown on the screen, to be the mechatronics. This is a new word that was introduced to the new English dictionaries. In our sense, the word mechatronics means a synergistic integration of these two fields of mechanical and electronic engineering. And we use the integrated principle of mechanical and electronics in design and manufacture of products, what I call mechatronic products. And this is really involving everyday life of ours. And it also is a product that almost all the industries that we can think of will be involved with using that technology, either in the design or production of the products, as I shown below. Well, how about us on our day-to-day life? Well, I'm sure many of us are using and familiar and using these two little devices. One is the thermostat that we control the temperature of our homes and buildings, and also the timer that we use it for a lot of things to control the operation of the home appliances, such as these, and also in our cell phones of different kinds. And you know what? Mechatronics was the base technology that we use in design and produce those computer data storage disks drive, and also the printers and plotters of computers. And more recently, perhaps less than 5 years in a time frame that we use mechatronic technology, primarily use large data and also proper software, and use of the 3D printers or plotters to design and build those houses, very simple houses, are called affordable houses, and all very sophisticated, comfortable houses. And this affordable house by 3D printers actually getting to be very popular in this country and also in some developing countries. And we can use this technology to build this kind of house, affordable houses, for less than $10,000. And it can be done to build one of these houses in the short time frame of 1 week. So imagine we have lots of problems for the home, try to get homes for homeless people, thousands of homeless people in this country. And imagine what this technology, new mechatronic technology, can do to help the government and those folks who do not have home to live. And another one good example that I hope you will share with me is the most commonly used mechatronic product, that is automobiles that we drive. My personal experience is that before 1970s, I was just merely driving a machine that to move me around to places. Then 10 years, 20, 30 years later, in 2000s, I'm not only driving a machine to take me around, but also I was driving a machine plus electronics. There are lots of electronics being included in driving trains of those cars. And then as we move into the millennia years now, in 21st century, I'm not only driving a machine, but I'm also driving electronics, and I'm also driving computers, microprocessors and computers, as we show in this picture. You know, all these evolution of automotive technology involving mechatronics make our life very easy in driving. But you know what? It also has make us handicapped and helpless to try to repair the cars by ourselves. I could not even replace the light bulb of my headlight of the cars, as everything nowadays has to be done by computers. But nevertheless, of the advantages, disadvantages, it's very clearly demonstrate to us that mechatronics is a multidisciplinary technology, and it is truly a challenge as well as a difficult task for engineering students and engineering educators. And that's why I determined to focus our educational effort to our students in mechatronics, and we established the nation's first and the only mechatronics curriculum STEM, that is one option in mechanical engineering. I can offer you tons of examples that mechatronics is every day with us in our lives. Well, first of all, we're aware of different types and shapes of robots that doing all kinds of different things for us. For instance, they play pianos, they play violins, and also we use mechatronics in our GPS that will help us to get around in strange places. And you have seen this picture before, perhaps, that robots are everywhere in the manufacturing floors. And also robots can be smart enough to cook gourmet dinners for us and do housework. Oh. Houseworks, cleaning, and also help the aged people like me, and also will help the patients some human nurse could not handle easily. So what can mechatronics, in a bigger picture, how can mechatronics to help us solving current world problems in humanity? Because we're talking about humanity all the time. We all know that the world is full of problems, but can we solve all these problems at once? My answer is no. So let's focus on two of these more urgent problems that we would use, we believe we can use the mechatronics to solve. And these two problems, problem one is how to feed millions of hungry fellow citizens in this crowded and hungry world. Well, if you look at this website, you'll be convinced that in today's world with 7.8 billion people, and half of them, that is more than 4 billion people, are living in the cities. And whether you agreed or disagree that all the crowded urban centers, like those I call the slum and ghettos, will bring us lots of problems, as we will show in the next slide. It creates, of course, ghettos like this, and the sharp contrast between the people living in the ghettos, people living in comfortable high-rise buildings. And create the problem is that it'll create ghettos and slums. Well, believe me, that's not very comfortable and happy place to live with, because I was one of them when I was young and a little boy. Those ghettos and slums, because of the lack of affordable housing and employment opportunities, so quite often, almost always create violence and crime. And also they don't have enough to eat, and they're hungry. And based on statistics by United Nations, there are 690 million people. That's a lot more than the population in the whole of this country do not have enough to eat. And of these 690 million people, hungry people, 130 million of them are starving. That means a desperate need of food. And all these people who do not have enough to eat and who are starving are in Central America, and Africa, and also in some other Mideast countries and regions. So if we can solve these problems, I think this problem, in my personal belief, that this would be the ultimate solution to also solve our border, illegal crossing of our southern borders from those undocumented immigrants from South and Central Americas. Because they're desperate in their home countries, home regions. So if we can provide them with good food and also clean water and healthy water for drinking, I'm sure that will remove all the excited that they want to cross the border illegally and risk of their life to do so. So how to solve this problem of to feed hundreds of millions of people, hungry people in the world? Well, actually, a senior staff of United Nations proposed to invest in sustainable agriculture in those countries and regions. And that is very, very costly propositions because part of my research was on sustainable economic development for the world. So it is my humble opinion that I think a more practical solution to this problem, to feed a massive starving people in overcrowded urban center, is to invest in what I call vertical farming, as I pointed here. Okay, so then the next question is, what is vertical farming? Well, vertical farming is to grow the plants in the farm stacks, and these plants can be wheat, can be potato or soybeans as food in those buildings, and either in the city or in urban areas like slum and ghettos, where there's very limited land available for growing food. And advantage of this is, as you can see, is that it requires minimum land areas, or I call arable land, to grow food in the ghettos or slums. And once it is set up, the residents, the inhabitants of those in the ghettos and the slums will grow their own required food. And food growth in those vertical farms will be consumed by local residents. So you can well imagine that there's no transportation and also in between parties involved for marketing and distribution of food. And another very good example is that good point is that fortunately we in the university, at least my colleagues in mechanical engineering and myself, we already have the necessary resources and track record of our scholastic work to solve these problems in vertical farming. And another thing that, of course, we need to supply these things to the vertical farming is what I call disadvantage. We need to provide the lights to those crops grown in vertical farm, and also control the shining angles, such as the sun radiations that's in the natural. And also we have to provide kind of the right water irrigation and humidity control, as well as supplied with adequate amount and timely fertilizing. In all, vertical farming, can we imagine it's just a greenhouse environment, or environmentally controlled greenhouse. So because this is a part of my scholastic work, as well as those of my colleagues in the department. So I believe that San Jose State University is well positioned to help to solve this problem. And another advantage is that we also can help our government federal government to solve this border crossing problem by illegal immigrants. And I bet you that the cost of investment on vertical farming is far less than what we have to spend on building the walls and also having providing accommodation for those underage illegal immigrants. So this could be another good opportunity for our colleagues in this university. Now, this is a problem one on feeding hundreds of millions of hungry people in this planet. And how about the problem two? Well, problem two is that we are living longer and we're living in dirtier environment. So problem two is that how to use mechatronics, and I believe mechatronics technology can help us in combating the climate change. So first, what is the cause of the problem of climate change? Well, the root reason for this problem is that we produce and release too much greenhouse gases, for example, CO2 gases and methane and hydrogen, this sort of thing. But in particular, CO2 gases is a common gas that emit from automobile, as I illustrated here. And these excessive emission of CO2 gas will create kind of shield that will entrap the solar radiation created heat on the surface of our planet. And this global warming created by CO2 gas emissions will cause, the obvious cause is the sea level rise by the huge amount of unprecedented amount of melting of permanent ice cap in the North and the South Pole of our Earth. And what they will do, well, it will create devastating consequences by global warming is the sea level rise, and that will cause many of the low-lying countries and lands underwater. And by end of this century, if we don't do something about to improve and solve the problem. Okay, so this is what I meant, one of those negative consequences. And also the extreme weathers will cause dramatic increase in tropical cyclones, hurricanes such as Katrina hurricanes in Louisiana not many years ago, and also unpredicted and unseasonal tornadoes. And one happened in South Carolina last night, as we know about it. And it will cause significant change in precipitations, like drought that we experience in California, almost as frequent as almost yearly drought. And a lot of other places that had unpredicted unseasonal freezing rains, drizzles, snows, such as in some northeast states, and hails, result in irregular fresh water supply in a world such as what's happening in California. A low crop yield with a reduced agricultural output, and because, believe it or not, this global warming also causes the pest to grow faster. So that not long ago, we know that in Southeast Asia, we had a low-cost problem. And also, it's more seriously that will cause massive retreat of glacier parks. My personal experience was that 20 years ago, when I took the family to the Great Columbia Glacier Park, we could see the ice on the roadside of the highways. But after 20 years, I revisited the same place. I had to walk uphill by 200 feet or more to see the ice. So how fast the glacier retreats in some part of the world. And this is a very serious ecological problem. And more seriously, it will cause lots of species extinct from our world. And by end of the century, the expert expected there will be 15 to 37% of non-species disappear on our Earth. And dramatic increases also, dramatic CO2 gas increase will cause increase in diseases and pandemics. And we should also remember what SARS was and Ebola in Africa countries, and are now the infamous COVID-19 pandemic. And the latest one caused 1.3 billion deaths on our Earth. 1.3 deaths of innocent life lost in this pandemic, as on 2 days ago. So it's really detrimental. It's not like our former leader said that global climate change is for faculty members in the university to seek grants from government. It's a lot more serious than what he said, as you can see from my brief introduction of this problem. So an easy way is to curtail the emission of CO2 gas from our cars. And I think you probably are aware of that there are 17 major countries in the world that already set the carbon neutrality dates, that is to ban the sales of fossil fuel powered cars by year 2030, and also joined by the United States of America in a couple of weeks earlier by our new President Biden. So again, I believe our university is best positioned to help in dealing with both of these problems as faced by the United Nations and human species of this world. Central Valley State University has unique mechatronic capabilities and strong R&D activities with the mechatronic, with the meteorology department, with which I collaborated in one of my research project related to climate change and renewable energy supply. And for emission-free vehicles, I guess it's appropriate for me to bring in my electrical vehicle. We call ZEM vehicle. ZEM stands for zero emission powered vehicles. And what's so special about our vehicle? Well, first of all, this vehicle was designed for lots of folks living in a very crowded cities, urban centers. So we will not promote expensive EVs. Instead, we try to design affordable electrical vehicles for those folks living in the city. not only that it is low cost, but also they're not powered by electricity alone, because electricity has to be generated by utilities, and lots of utilities still burn fossil fuels to generate electricity that we need to power that many electrical vehicles. You know what? A very informal paper that I present in a conference related to energy, renewable energy generations. The name of the paper I remember is called Sustainability of EVs. This paper was presented in the conference. I just didn't have time to write into a paper for journal publication. But this paper turned out to be very, very popular by folks in the renewable energy and electrical vehicle industries, because I have feedbacks from them from all the time in recent years. And also this vehicle was powered by various sources other than just the electricity from utilities. So it can be powered by human paddling. It may sound ridiculous to you or strange to you that we can use human paddling power to drive a vehicle, but that time, remember, this vehicle is specially designed for urban centers or cities. And lots of times we cannot drive the vehicle very fast. So it's also paddling, use human paddling to drive vehicle in slow speed in heavily congested urban streets. So this way, you see, you don't have to use electricity to drive your cars, and you end up saving lots of electricity by using human paddling. Well, if you're stuck in heavy congested traffics, it's not only that you save the electricity, but also have a good physical size for the drivers and passengers. This vehicle is designed for multi-purpose, for commuting back and forth from workplace, and for light utility works like what you see in Taylor our repair and maintenance trucks, and also for urban errand runs, for instance, for courier services and delivery trucks. So the vehicles are low cost in acquisition and also maintenance, plus reliability are the two fundamental considerations in design and manufacturing of our ZEM vehicles. And another advantage, huge advantages, is that if you use this ZEM vehicle to commute to work in office, and if you drive in a brilliant day like today with lots of sunshines, and you park your car at the company's open lot under the sun, and you know what, after you quit for the day and try to use your vehicle to go home, and you'll find that your vehicle is fully charged by the solar panels that it carries. And so if we have more of these ZEM vehicles, then we can skip the use of charging stations that lots of EV manufacturers today are investing in building this kind of charging stations. So why we choose to install the the mechatronics program at SJSU? So that's a good question. And I'd like to explain to you why I choose this particular technology for our department when I first came to this university. Well, as you know that we installed this program, mechatronic technology, in our education system with close to $500,000 from National Science Foundations, and with additional $54,000 from the international programs of the same foundation, and also with additional supports by mechatronics industry in the Silicon Valley of equipment and also hardware and softwares, altogether add up to close to $1 million in cash. With this amount of money, the colleague and I in our department and electrical engineering department, we established the curriculum STEM. Okay, and this STEM started in the spring of 1996, seemed to be a long time ago. And with 43% of our NE majors enrolled in this curriculum STEMs. This STEM includes 14 altogether with 14 courses, including 5 new mechatronic courses that we developed with this fund, and the new labs for this. Okay. And why I recommend this program for the department. Number one is it was an emerging technology at that time. And Silicon Valley was actually the leader in this with computer disk drive and also semiconductor fabrication. So as a mechanical engineer, myself, I always fascinated how to use of this manufacturing product using mechatronics technology. Number two motivations that I, as a newcomer to San Jose State and Silicon Valley in 1990, I was asked to lead the mechanical engineering department and also to think about what the good things that we can do, not only for my own department and also for the companies and industry in Silicon Valley and the communities that support our universities. So I managed to find the answer to this problem from the mission of our university, which read as follows. Namely, we are supposed to in service to our society, that is Silicon Valley, and our community, a Silicon Valley community, and also to expand our knowledge through research and scholarship. So research should be part of our faculty's duty. Well, I then developed 9 steps in a roadmap to get my dream to reality. I think the first 5 steps are very important. Step 1, 2, 3, and 4 and 5. Step 1 is that although I was so positioned as a department chair, but without the department approval and support, nothing could happen even to any able chairs. So I need to get their support and also approval of what I'm thinking for the department. Then not enough, I also have to report to the dean and associate dean, as well as I have to secure my support from the chairs of the sister engineering department that have their faculty members, the colleagues to join my team to develop the proposal on mechatronics technology. Number three, to prove to our potential funding supporters, I have to tell them that this mechatronics is what the local industry needs. So our team with the members from mechanical electrical engineering, we identified and selected 40 of these mechatronics business and industry in the valley. And we paid the executive of every one of those 40 companies in the valley. So after done all these three steps, we are ready now to visit the National Science Foundation. The reason for our visit, instead of writing a proposal, was because I realized that this is a lot more than the usual proposals that we submit to the National Science Foundation. This proposal is going to involve what I call a huge amount of, I call it block funding. That includes equipment, personnel support, and also the compensation of faculty members of traveling to visit other industry and institutions. So that's a very important visit by us, three of us, myself, and a senior staff member from research foundations, and also another colleague from chemical material engineering department. So I learned a lot from these visits. More importantly, I learned, number one, is that the National Science Foundation has much larger annual budget than the budget of the research grants that they hand out. Number two is that I learned that many of them have, I call, outdated mindset about the state universities. And in my subsequent article on the history of mechatronics curriculum STEM, I would give you more detailed conversation that I had with one of very senior officials of National Science Foundation on this issue, that why state university needs their help in education. And then we are ready now with credible justification. We're ready to develop a proposal. And it's really by myself, with my colleagues, with their feedbacks. And we submit the first proposal over $1 million budget and 7 new laboratories, 3 new laboratories and 7 new courses. Okay, altogether for over $1 million. But you know what? Despite all the work we did in step 1 to 5 to have this proposal done, we were not funded. Our proposal was rejected by a National Science Foundation, but they sincerely advised me that our proposal was a good proposal and they're willing to fund, but we asked too much money to do it. So I accept their suggestion very seriously, and also try to understand the reviewers' comments. They're all good, except that they said we need to do more on the issues, why mechatronics education is important, and what are the potential impacts, as well as how we deal with issues of minority students and our external evaluation. So That's what we're missed in my first proposal. So we revised our proposal and resubmit the proposal again in the following year. It was reduced the budget to little less than $500,000 after we assured that the university would support us and also local industry. So 4 months later, a long waiting time. Finally, we got very positive award notice from NSF at the values that as I indicated before. This amount of money that NSF award actually was $5,000 more than what we proposed. That is a very rare occasion. So what I'd like to share with you then is that the spin-off, after we installed the mechatronics curriculum STEMs in our department. After 3 years, we did this. Members of the team returned to our own scholastic work or research work. Okay, and this is how I got to be interested in STEM education, because everything's moving forward, so is mechatronics education. So I learned from the 2 workshops that I was asked to host. One is nationally with faculty members from all over other parts of the country. Another one is from 6 countries from Asian Pacific regions. Those are the leaders which dominate our market in consumer electronics, which I call mechatronic product, like autofocus cameras and video cameras, and also flat panel television. So these people have their unique ways in developing their human resource to create those dominant markets in the United States, for instance. So of these spin-off of one of my interests, so we have to think what will be the future mechatronics in education and human resource. So that's how I got to be interested in human STEM education. Well, STEM education, simply put, it stands for science, technology, engineering, and mathematics. It was invented by a lady from NSF 20 years ago. So I started my research work in STEM education about 5 years ago. And because of time limit, I will ask that we start the next portion of my presentation. That's question and answer Q&A sessions. Thank you.
Thank you so much. I really appreciate it. Want to make sure we got a few minutes for some questions for you.
Okay.
So one of the first ones that came through is sort of around sustainability. And can you hear me well?
Sorry, I ask Leslie to tell me what the question was.
Oh, I haven't gotten to it
because I'm
yet.
hard of hearing.
Oh, okay. Can you
Sorry
hear
about
me?
that. Yeah.
Okay. So there's a question about sustainability and
Yes,
economic
sustainability,
principles.
like what I explained
Yeah.
to you earlier, is that now that we have installed mechatronics curriculum STEM with fairly general support from NSF and community, but things have to move on. And I foresee, as I learn from those colleagues from other universities in 2 workshops that I was asked to host, that they have different views and their country have different human resource development in mechatronics. So I think we have to think about what would be next of our mechatronics education for our university. So I was therefore more interested in education, and STEM education seemed to make a lot of sense to me. So I focused on STEM education. But I found out, despite the fact that STEM education is excellent education system for us, but after 20 years, there was very little progress that I have heard about it. I think one of the problems that the general mindset of our fellow Americans in mathematics. And then I found out how mathematics was taught to the lower division of our students at San Jose State. They're taught separately from other 3 disciplines like physics, of science, mathematics, physics, and engineering technology. So students learn the math really very well. Even that I'm questionable. In my course that I taught on engineering analysis, a lot are very good to be reminded how to drill, like how to do integration, how to solve nonlinear equations. But when I ask them why you solve those differential equations in one of your lower division courses, Math 133A to be particular, then they said, well, because it's in the book that we're asked to learn to solve. Well, this is the equation that my professor asked me to solve. Why this particular differential equation? They stuck no one of almost 100 students that I asked, no one gave me any answers. And also, I was asking many times, I'm sure you do too, Provo, that what do you do for a living? You explain to them, your university professors. Then they said, what do you teach? I said, I teach engineering analysis. And what in engineering analysis? I said, lots of math. Then, it never failed. They said, oh, that's very, very difficult topic to me. I don't want to have anything to do with it. So then I got the key. Yes, indeed. I could never find any textbook on STEM education that integrate all these 4 sub-disciplines together to make our students easier to learn STEM and also take full advantage of STEM education. This I have since developed for some examples. Mechatronics, like what I mentioned earlier, is in our day-to-day life. Mathematics also is at our day-to-day life. I try to say that, for instance, Goldilocks for preschooler. Good story of Goldilocks and the 3 bears. I learned when my children were little. Okay, Goldilocks found the first bowl of porridge too hot. How could she make a porridge cooling faster? So she could stir very quickly. So stirring quick of hot stuff, and also the wind chill factor that we face when we walk outside the street in cold winter days. I used to live in Canada, I know how cold it could be. Okay, how can you relate the two? Actually, we could use exactly the same math to handle both problems, to design both cases. For instance, how quickly you can stir the hot porridge for Goldilocks, and why cold winds blow over your face and make you feel colder. Okay, then for high school or college students, I said, can you tell me what's the principle of human-made satellite orbiting on our Earth? you had physics, you had dynamics, and how to relate the orbiting satellite to the clothes washing machine in your basement. You know, when you're in the dry cycles, you have a fast spinning of wet clothes and squeeze out the water through the perforated barrel. Actually, the same principle, same mathematics can be used to solve both. In satellite, we know that there's centrifugal force, and we know gravitational force. If you have a balance of the moving satellite, and this satellite will circle the orbit forever for you, if you can maintain the tangential speed of the satellite. So I think if we can let our young Americans relate the math with their day-to-day life, I think we have a much better chance of success.
That sounds awesome. And it's a great way to get parents to make their kids do the laundry. All right. With that, I'm going to have to end it now because we're out of time. But I want to thank you so much for a really outstanding presentation and for everybody who joined us. There's a few more questions. We'll make sure they get to you so that you can answer them with your colleagues as well. But for now, I want to thank everybody and thank Dr. Hsu so much for an outstanding talk. Thank you.
You're very welcome, Bravo. And I hope that whatever we do, we'll have your support.
Absolutely.
Thank you. And thank you for being here to support me.